Imagine you're waiting for that really crucial update, right? Maybe payment processing, or perhaps a sensor trip somewhere, a new sales lead.
Something important just happened.
Exactly. Now, do you want your systems just constantly, anxiously checking, pinging away? Is it done yet? How about now? Anything?
Ugh.
Or do you want that info just delivered like instantly right to your digital doorstep the second the event actually
That's
happens?
a push model, definitely.
Mm-hmm.
Pulling that constant checking, it's like, I don't know, opening your fridge every 30 seconds hoping milk has magically appeared.
uh, yeah, it's just inefficient.
Totally inefficient, resource heavy, and honestly, it feels a bit desperate from a system perspective.
Right. And that instant event-driven delivery, that's really the core idea we're diving into today. Webhooks.
Hmm.
We're going deep on how webhooks give you that instant reaction capability and, maybe more importantly, the often kind of messy reality of integrating different software systems using them.
Yeah, that integration piece is key. We've pulled together insights from, well, quite a stack of material for this deep dive. We got guides on database admin, system architecture,
So the foundational stuff.
right, context on data consistency, logging, things like that, but also specific articles on API patterns, troubleshooting guides, and, detailed breakdowns of how webhooks actually work from various providers.
Okay, so our mission here is to get beyond just the definition. We want to really understand what webhooks are, how they work technically, sure, but also the real advantages
And the pitfall.
and the pitfalls, yes. The common challenges and the ways people actually solve them to make these integrations work, well, make them reliable, scalable. Let's unpack this.
Sounds good.
So let's start right there, that fundamental shift. What is a webhook really, and how is it so different from that constant checking, the polling we talked about?
Okay, so at its heart, a webhook is basically an automated message. It gets sent from one application, the source, to another, the destination, when some specific event happens.
Right, it's the push.
It is the push model. Exactly. The source system effectively says, hey, guess what? This thing you care about just happened, and it sends the relevant data over automatically.
Which is the big contrast with the pull model polling.
Precisely. Polling's let's call it the old school way. Your application, the client, has to keep asking the server, anything new, any updates for me, now,
On a loop.
on a schedule. Yeah. Maybe every few seconds, maybe every few minutes. It's like you calling the pizza place over and over. Is my order ready yet? Is it ready now?
Which, okay, maybe that's fine if you expect updates really frequently, but what if the thing you're waiting for happens like once an hour? Or once a day?
Then you're just wasting resources.
Mm-hmm.
Request after request, eating up bandwidth, CPU cycles on both ends, just to hear, nope, nothing yet, 99% of the time.
Uh-huh.
Webhooks completely flip that. The pizza place calls you the moment your order is actually ready. The source system pushes the notification, the data, only when the event actually occurs.
So the big win here is efficiency, right? Especially for those less frequent events.
Absolutely. Huge efficiency gain.
Yeah.
You cut down massively on pointless network traffic, server load, and the destination system. It gets the info pretty much in real time.
Makes everything feel more responsive.
Much more responsive. And thinking about scale, webhooks tend to handle increasing event volume more gracefully. Scaling polling often means polling more often, which could just swamp your systems.
Okay, concept makes total sense. Get notified, don't keep asking. But how does this automated push actually happen? What's the technical flow?
It's actually pretty straightforward, built on standard web stuff, usually HTTP. So an event happens in the source system. Let's say a new user signs up.
Okay.
That triggers the source system to make an outbound HTTP request. Typically, it's an HTTP POST request.
All right.
And it sends it to a specific URL.
The webhook URL.
Exactly, the webhook URL or endpoint. That's the address the destination application provides beforehand, saying, send your notifications here.
And the details about the sign up or whatever the event was, they go along in that request.
Yep, exactly. The data about the event, we call that the payload, is put into the body of that HTTP request. Nowadays, that's almost always going to be in JSON format. Could be XML or form data sometimes, but JSON is dominant.
And what does the source system, the one sending the webhook, expect back? Just a quick, got it.
Crucially, yes. That's a key point. The provider, the sender, it just wants a very quick confirmation that the message was received. A simple HTTP 200 OK status code is a standard signal for, yep, received, thanks.
So it doesn't wait to find out if the receiver actually did anything with the data yet.
Generally, no. It's designed to be fire and forget. Send, get the 200 OK, move on. The provider usually isn't concerned with the downstream processing, just the successful delivery of the notification itself.
Okay. Now, I've seen sometimes there's like a verification step first, before they start sending real data.
Ah, yeah, that's a good practice some providers use for reliability and security. It's like a handshake.
Right.
Before sending actual event data, they might ping your webhook URL first. It could be an HTTP options request, just to see if the URL responds. Or sometimes they send a special first request with like a challenge code, and your endpoint has to send that code back correctly.
Just to prove it's the right place and it's listening.
Exactly. It confirms the URL is valid, it's active, and it's actually controlled by you, the intended recipient. Helps avoid sending data, potentially sensitive data, into the void or to the wrong place.
Like checking someone's actually home before you leave the package.
Perfect analogy.
Yeah, okay, so the provider sends the webhook, hopes for that quick 200 OK, and considers its job done. That brings us to the other side, that the consumer. What does this mean for the architecture of the application that's receiving the webhook, especially with that fire and forget thing?
Right, and this, according to the materials we looked at, is where integrations can often get tripped up.
Yeah.
The absolute critical thing is the system receiving the webhook should not try to do a bunch of heavy lifting, time-consuming work synchronously.
Meaning, not right there in the code that handles the incoming request.
Exactly. Because the provider is sitting there waiting, maybe only for a few seconds, for that 200 OK response.
Yeah.
If your webhook endpoint immediately tries to, I don't know, update complex database records,
Right.
call out to 3 other external APIs, run a big report, that could take several seconds, maybe way longer.
And the provider's timer runs out,
Provider times out, yeah. It assumes the delivery failed because it didn't get the quick OK.
and then it tries again later.
Almost certainly.
Yeah.
Most providers have retry logic built in. If they don't get that 200 OK reasonably fast, they'll queue it up and send the same webhook again later, maybe multiple times.
Which leads to duplicate notifications hitting your system.
Messy.
Very messy if you're not prepared. So the recommended pattern, the robust way to handle this, is acknowledge fast, process later.
Okay, break that down.
Your webhook endpoint code should do the bare minimum, receive the request, maybe do a quick validation, like check a signature if the provider sends one, send back that 200 OK status code immediately, and then take the payload, the actual data, and hand it off somewhere else for processing. Hand it off how? What's the typical way to do that handoff?
The most common and reliable pattern is to put that payload onto a message queue. Think of it like a durable, reliable inbox for tasks.
Like Amazon SQS, RabbitMQ.
Exactly those kinds of tools. Your endpoint just drops the message onto the queue, which is a very fast operation, and it's done. Then you have separate worker processes, maybe running on different servers or containers, whose only job is to pull messages off that queue and do the actual heavy lifting, the processing.
So it decouples the receiving from the processing.
Totally decouples it. The webhook reception stays fast and responsive, meeting the provider's expectations. And the actual work happens asynchronously at its own pace without blocking the initial receipt. It makes the whole system much more resilient to load spikes or slow downstream tasks.
And this asynchronous pattern, dealing with queues and workers, that's where idempotency becomes absolutely critical, right? Because of those potential retries we mentioned.
Oh, non-negotiable. Absolutely vital. Because you know you might get the same webhook notification more than once. Network hiccup, provider retry, whatever your processing logic must be able to handle that gracefully.
Meaning processing the same event data 5 times should have the same end result as processing it just once.
Precisely. That's idempotency. You need to design your worker logic so that if it processes the exact same event notification multiple times, it doesn't create duplicate database records or send multiple emails or charge a credit card twice.
How do you usually achieve that?
Often, the webhook payload will include some kind of unique event ID. Your processing logic should first check, have I already successfully processed an event with this ID? If yes, you just acknowledge the message off the queue and do nothing more. If no, then you perform the action and record that you've processed this ID.
Got it. So that handles the receiving side reliably. But okay, you've got the data in your system now, maybe sitting on a queue. That's just step 1, right?
Yeah.
Making it actually work with everything else. Let's zoom out. What are the big, broad challenges of system integration in general? Things that hit you, whether you're using webhooks or APIs or anything else.
Right, because even if your webhook delivery is technically perfect, you slam right into the classic integration headaches that, the sources cover in detail.
One that always seems to come up is data mapping and transformation and
Yeah.
keeping things consistent.
Oh yeah, that's a monster. It's almost guaranteed that System A stores data differently than System B. Different field names, different formats for dates or addresses, different unique IDs for the same customer or product.
Different meanings even for fields that sound similar.
Exactly. Semantic differences. Trying to translate data between these different schemas and meanings accurately is really, really hard. The sources consistently point this out as a major source of errors data getting lost, corrupted, misinterpreted. These can be silent failures, too, that you only discover later when reports are wrong or processes break down.
And you might be getting data in one format, like JSON from the webhook, but needing it somewhere else in, I don't know, CSV or XML for a legacy system.
Yep, JSON, XML, CSV, Excel files, maybe even unstructured text blobs sometimes. You need robust transformation logic to handle all that. And it needs careful design and ongoing maintenance because systems change.
Okay, another big one, security. Integration must open up new security considerations.
Huge ones. Every time you connect two systems, you create a potential attack surface or point of failure. You absolutely have to nail authentication, proving who is making the request, and authorization, proving what they're allowed to do.
And this is where things like API keys come in.
Oh, oof. Right. Managing API keys securely, implementing oath flows correctly, handling errors like a 401 unauthorized or a 403. Forbidden, these are common integration challenges. Getting authentication or authorization wrong is a frequent pain point.
And the sources mention some specific warnings, like with JWTs.
Yeah, that's a critical technical detail that came up. If you're using JSON Web Tokens, JWTs, for passing identity or permissions around, you must validate them properly on the receiving end. Check the signature, check who issued it, who it's for, if it's expired.
And there was a specific dangerous setting.
The ALG, none header. Allowing that basically means you're telling your system, trust this token even though it has no signature. It completely bypasses the security benefit. A massive hole if you allow it. And beyond the technical stuff, you've got compliance, GDPR, CCPA, MARIAPIA, depending on your industry, and data. Making sure sensitive data stays protected as it flows across system boundaries is crucial.
Scalability and flexibility also seem like recurring themes.
Definitely.
Yeah.
Whatever integration solution you build, you have to ask, can it handle growth? What happens if the number of webhooks jumps tenfold? Or the size of the data payloads increases? Can your integration points, your queues, your workers scale out?
Or are you stuck?
Right. Under-engineering for scale is a classic mistake. It leads to performance bottlenecks later or forces expensive, rushed rewrites when things start failing under load. And flexibility is about adapting. Source systems change their APIs, destination systems update schemas. Your integration layer needs to be adaptable, not brittle.
And interestingly, the sources didn't just focus on tech. They really hammered home the people and process side of things.
Yeah, and I think that's often where the deeper insights are beyond just the code. Things like unclear business requirements. If you don't really know why you're integrating or what the end goal is supposed to look like.
Your tech solution won't hit the mark.
Exactly. Or maybe a lack of the right technical skills on the team.
Yeah.
Or just poor planning. These can absolutely sink an integration project, even if the tech choices were sound on paper. A really common theme was underestimating the complexity.
Treating integration like it's just, connecting some pipes, plumbing.
Precisely. It's often viewed as this purely technical IT task. But successful integration, especially complex integration, needs to be treated as a strategic business initiative. It needs clear ownership, cross-department collaboration, strong project management. Without that strategic view, all the technical hurdles just become harder to overcome.
Okay, so we've covered what webhooks are, the push versus pull, how they work, the challenges of consuming them reliably with async processing and idempotency, and these broader integration hurdles like data, security, scale, and process. Now, the inevitable part, troubleshooting. Things will go wrong. When your carefully crafted webhook integration starts misbehaving, how do the experts suggest you actually figure out what's broken?
Yeah, troubleshooting integrated systems, it's detective work, pure and simple. The failures often aren't just obvious bugs in one place. They show up as weird symptoms impacting the business orders getting stuck, customer data being inconsistent, things like that.
So where do you even start looking when the problem could be in the source, the network, your endpoint, the queue, the worker, the downstream system?
The sources are really unanimous on this. Logs and metrics are your absolute best friends, your lifeline. Access logs show every single request, who called what, when, what was the response code. Error logs capture exceptions, stack traces. Performance logs track latency. How long did things take? Security logs flag auth problems.
And metrics give you the higher level view.
Right. Metrics track things like error rates, average response times, queue lengths, system availability, traffic volume. Seeing a sudden spike in 500 errors or latency climbing or messages piling up in a queue that points you where to dig deeper in the logs.
And correlating events across all those different systems must be key.
Oh, absolutely vital. A single business transaction might trigger a webhook, go through a queue, get processed by a worker, which then calls another API.
Yeah.
You need to be able to follow that specific event's journey across all those hops.
Which sounds hard if logs are scattered everywhere.
Exactly why centralized logging is so crucial for anything non-trivial. Tools like the ELK stack, Splunk, Datadog, getting all your logs into one searchable place, ideally with some standardization in format and maybe a correlation ID that travels with the request, makes tracing those distributed flows possible. Without it, you're often flying blind.
Okay, let's drill into API errors specifically. When you're troubleshooting, what are those key HTTP status codes you really need to understand?
Developers doing integration work basically need to know these by heart. You pay super close attention to the formoxx range.
Mm-hmm.
Those are client errors, meaning the problem is likely with the request you sent. 400. Bad request, your payload or parameters are probably wrong. Malformed JSON, missing field. 401, unauthorized authentication failed. Bad API key, missing token. 403, forbidden you authenticated okay, but you don't have permission for this specific action. 404, not found the URL endpoint or the specific resource you asked for doesn't exist. 429 sitter miles. Too many requests, you're hitting their rate limits.
Okay, those are our fault, potentially. What about the other side?
Then you have the 5MyX range server errors. These mean the problem is likely on their end, the system you're calling. 5 internal server error is the generic, oops, something broke over here. 503, service unavailable, usually means the server is down, overloaded, or undergoing maintenance.
So first step is check the error code.
Check the code, and immediately go check the API provider's documentation. Good docs will explain what their specific errors mean and what might cause them. And double-check your request structure, headers, body, parameters against their spec.
We talked about providers retrying failed webhooks to us. What about when our system needs to retry calls out to other services, maybe from our worker process? How should we handle those failures?
Yeah, that loops back to building resilient systems. Your code needs a smart retry strategy for its own outbound calls. The standard technique is exponential backoff.
Meaning you wait longer each time you retry.
Exactly. First retry might be after 1 second, then 2 seconds, then 4, 8, and so on. You exponentially increase the delay. This avoids hammering a service that might be temporarily struggling.
Smart.
And a really important nuance that came up in the sources, add jitter.
Jitter.
Yeah, add a small amount of randomness to that exponential delay. So instead of retrying it exactly 1, 2, 4 seconds, maybe it's 1.1s, 1.8s, 4.3s. Why? Because if you have many instances of your worker all failing and retrying at the exact same exponential interval,
They all hit the recovering service at the same time.
right, you get these synchronized waves of retries, a thundering herd, which can knock the service back down again. Jitter spreads out the retries, also crucial. Monitor your retries, log them, put sensible limits on the maximum number of attempts or total time you'll wait. And be smart. Don't retry indefinitely on errors like a 404. Not found, the resource isn't magically going to appear. But a 500 or 503, that might resolve itself, so retrying makes sense.
Gotcha. Any other handy troubleshooting techniques mentioned for dealing with all this complexity?
Isolation is a big one. When you have flow involving multiple systems and something breaks, it's hard to know where the fault lies. Using techniques like mocking or stubbing in your test environments helps.
So you pretend to be the external service.
Yeah, you create a fake version of the external API that your code calls. It just gives back predictable responses. This lets you test your code in isolation to see if the bug is there, or if it really is the external dependency that's failing in production. And application performance monitoring, APM tools were mentioned too. They give you that real-time dashboard view of system health, performance bottlenecks across your whole distributed setup.
And it sounds like documentation isn't just for setup, it's vital for troubleshooting too.
Absolutely. Every time you troubleshoot an issue, it's a learning opportunity. Documenting what went wrong, the symptoms, the steps you took to diagnose it, what the root cause was, how you fixed it, that builds invaluable knowledge for the team. It makes the next incident faster to resolve and helps you spot patterns to improve the system's overall resilience.
So let's bring this all back to you, the listener. Whether you're actually building these systems or maybe managing the infrastructure they run on, or even if you're just relying on services that need to talk to each other behind the scenes, understanding webhooks and these integration realities is, well, pretty valuable.
It's about moving beyond that frustrating old polling model towards systems that are genuinely responsive,
Yeah.
that react to events as they happen. But it's also about going in with your eyes wide open,
Hmm.
about the challenges involved in making different pieces of software actually cooperate reliably, securely, and at scale.
Yeah, it helps you ask better questions when you're designing or choosing solutions. You'll have a clearer idea of what to look out for, what patterns to use, and maybe a better plan for when things inevitably do go sideways in your integrated
Well,
systems.
that's why.
Reflecting on all the material we dug through for this deep dive, the really strong takeaway for me is that yes, webhooks offer this technically elegant way to build efficient, responsive systems,
Well,
but the path from that technical blueprint to a truly reliable working integration often hits some serious bumps. And it's not always just the tricky code. It's underestimating the complexity. It's those data mapping nightmares. It's the security checks at every step. And it's needing that strategic oversight, not just treating it as an IT plumbing job.
yeah, the technical promise meets the organizational and data reality. It's a classic scenario.
It really makes you wonder, doesn't it? When you're integrating systems using webhooks, does the elegance of that push model usually win out? Or does the sheer messy reality of differing data, security hurdles, and, organizational friction tend to dominate the outcome?
That's a great question, and probably one worth asking every single time you start designing or debugging an integration.
Something to think about. Thanks for joining us for this deep dive.
Until next time.